welcome everybody to this week's Rough Cut. So first I want to thank those of you who came to the happy hour on Friday. Good times had by all. I want to encourage you to come throughout the semester. Highlight in a couple weeks we have Bill Schlesinger coming as our distinguished visiting lecturer. So he'll be giving a rough cut. And then on Thursday evening he'll be giving an open talk at Sub, which is kind of more big picture stuff. So we're looking forward to that. If you're interested in meeting with Bill Schlesinger while he's here, let me or Anna know, and we'll see if there's room on the schedule. We think we still have a little bit of room left. Okay, for today's rough cut, we're very excited. Travis Belote is going to be here with us. He's a research ecologist with the Wilderness Society at their Northern Rockies office here in Bozeman. He got his master's from the University of Tennessee and PhD from Virginia Tech. And he was a postdoc at USGS in Flagstaff. He's done a wide range of research on the effects of fire on biodiversity, the effects of climate change on invasive species, impacts of alternative timber harvesting disturbances on forest resilience. He's worked in rangelands. He's collaborated with several faculty at University of Montana and MSU. He's published extensively. Today he's going to talk to us about some of his work that he's doing on large-scale spatial data to map wildlands and climate change vulnerability. I'm looking forward to it. Take it away.
Thanks so much for having me. Thanks for inviting me, Anna. Just we'll do a check here. Okay, that's not working. There we go. So I just wanted to start off doing a little bit of introduction on where I come from and what I sort of grew up studying. When I mean that, sort of where I started my academic training, what I focus on with my research up until the past, say, year and a half. What I like to talk about is the fact that I spent most of my training on my hands and knees looking at things at small scale. So this is me sampling vegetation at the FACE site, the Free Air Carbon Dioxide Enrichment Facility at Oak Ridge National Lab, which is where I did my master's work out of the University of Tennessee. For those of you that don't know these experiments, this is one of a global network of sites looking at what are the impacts of an enriched carbon atmosphere on different ecosystems. The one at Oak Ridge is focused on deciduous forest. This was a sweet gum plantation, so not quite a deciduous forest, but a model system where they basically were emitting carbon dioxide and enriching it to a level that's predicted in 100 years, at least back at that time, was 100 years. To look to see everything from carbon pools to turnover, sort of the carbon dynamics of a forest. What I was doing is looking at the community composition of the understory. So how does the community of the plants are influenced by elevated CO2, with a particular interest in how invasive species were influenced by CO2. So from there I moved on and did some work. Spent a couple of years with the Park Service, came back and did a PhD at Virginia Tech where I was looking at the effects of timber harvesting, basically for different disturbances that we harvest timber with in the Appalachian forest, and again, mostly getting on my hands and knees and looking at how plant communities responded to things like a canopy disturbance, everything from uncut to clear cut. Again, with the focus on how does plant community diversity, composition, and invasibility are influenced by disturbance. Then I did a postdoc at USGS in Flagstaff working on the Colorado Plateau, basically looking at how do disturbances in the order of fire or grazing and overgrazing and energy development influence the plant community in terms of perennial grass cover as well as biological soil crust. So if you've ever been down to the Colorado Plateau, you know that they have signs around there that say don't bust the crust, you don't want to get off trail and influence these and impact these biological soil crusts that armor the soils. And so I was looking at how different management approaches influenced things like wind erosion. If we were to reduce plant cover and influence the biological soil crust, how did that influence something like the persistence of the soils on a site? And then finally moved to Montana 7 years ago and have been focusing heavily on fire ecology. So how does the return of fire regimes in the Northern Rockies influence things like forest community composition, structure, and then how do we apply that understanding, that ecological understanding of fire to restoring fire regimes in places that have been sort of out of whack because we've been putting fires out. So what I like to say is I've done enough, worked in enough different systems and been kind of a generalist, just enough to be insecure about everything. So, you know, spending a lot of time on elevated CO2 for a few years and then moving over and doing some timber harvesting stuff and working in Virginia Tech and working in different systems, it's given me a pretty good overview of all the ways that sort of what somebody might call factors of global change impact a variety of ecosystems, from, you know, deciduous forests and elevated CO2 to altered disturbance regimes, altered land cover, altered land use in a couple of systems, and then altered disturbance regimes in the Northern Rockies. So that's sort of that's my academic background for those of you who don't know me. And then that kind of creates the models that I bring to bear on working for a conservation organization and trying to apply ecology to a variety of questions that we have, like what are our models of restoration? How do we engage in restoration and do it right so it has a mind to the ecology of the areas? But also, what are sort of our needs in terms of a conservation reserve and protected areas, additional protected areas? The thing that's pretty clear now is that these elements of global change, so all, you know, enriched CO2 atmosphere, changes in climate, invasive species, altered land use, it challenge our sort of traditional notions of conservation. So this is very oversimplification admittedly here, but if you think about two branches of what we might call conservation being restoration and protected areas designation, from a restoration perspective, what does climate change do in terms of what do we use as a target for restoration? Do we focus on historical ranges of variability to try to restore the historical components of an ecosystem? Is that our target for restoration? Or under a changing climate, do we have to adopt new future ranges of variability, or the concept of novel ecosystems that we're trying to restore to? So global change challenges sort of that, all the sort of field of restoration ecology, and at the same time, it challenges this sort of idea of protected areas and protected area management and wilderness designation. So under climate change, do we value self-willed nature that the Wilderness Act provides under those lands? But if climate change is going to impact the ecosystems that those protected areas are intended to protect, do we have to intervene to sort of maintain that biodiversity? So I'll get into the details of what I mean by all this, but just sort of to set the stage of where I came from, and then these two big fields that at least I pay attention to with how to apply ecology to conservation work, and then the challenges that we're running into as a science really with climate change. Like, what are our models? And I think as ecologists, it's sort of, you know, it's our duty to wrestle with these things and provide some guidance. And so that's sort of what I do with my job, and what I'm going to be talking about really is sort of the context here. So just to show some examples of this sort of challenge to restoration, this sort of idea that we're restoring to this model of historical range of variability. This is a quote from I listed, you know, cherry-picked out of one of Bob Keene's papers, basically saying that using this historical reference may no longer be reasonable in this rapidly changing world. So if we're trying to restore ecosystems, do we use that historical range of variability as our guide? And then at the same time, sort of from the protected area standpoint, Peter Kariva wrote this: the reality of human footprint renders the discussion about what areas of the world to set aside as wild and protected areas as somewhat irrelevant. So under a changing climate, is wilderness still a relevant conservation strategy? Setting aside lands that are self-willed nature, is that the best way to preserve the biodiversity of places? So again, sort of how does climate change sort of create these challenges to these big efforts of what we might call conservation as a whole, conservation biology? So I guess I just want to point out that there's a growing number of people that are pointing out that these traditional views of conservation are still relevant. So this paper just came out literally this week. James Watson, who came here I think in February this past year, if anybody got to meet him, protecting the world's last wilderness areas, and not to say the sort of legal definition of wilderness area, but big intact lands that have minimal human influence. Protecting those last wilderness areas are the best prospect for ensuring that intact ecosystems and evolutionary processes persist for the benefit of future generations. So that, he's not saying like, oh, we can't have any more wilderness areas, we can't have untrammeled self-willed nature. He's saying that those are actually priorities from a conservation perspective. And then this Martin et al. Paper that came out in PNAS just a few years ago Dan Simberloff was an author on this, basically made the same point that, there are places that are still wild out there that those should be conservation priorities. So it's a bit of a contradiction to the idea that that's no longer relevant, which was what Peter Kriebel was saying in that one piece. So again, this idea that this traditional conservation, even though they're being challenged and increasingly becoming, a bit of a challenge for people like me that are trying to apply the ecological science to policymakers and managers making decisions, there are these traditional conservation principles that people are still using. So the protecting wild areas is still a priority, and then creating a completed system of protected areas is also a priority. So we're not done. We have, 110 million acres of wilderness, and that's not including all the other protected areas out there, and that we're not done, that we should complete that system of protected areas. So this paper just came out from Jocelyn Eicher colleagues, some of which here local, that basically sort of look to the future and say, okay, we've got this over 100-year legacy of protecting areas, creating these conservation reserves, but we need to do more. And so we need to create a more protected area system that's more representative of all of the ecosystem and nature's diversity, as well as one that's connected. So again, that's kind of setting the stage here, and I'm going to get into some of the details here in a bit. But what I'm going to be focusing on, for at least for the first part of the talk, is talk about concepts of wildness, like what do we mean by wildland, and then in the context of that, what we did to sort of design this landscape assessment to say, okay, if we do want to complete the system of protected areas, knowing that that's still a relevant conservation measure, where are our priorities of that? And then how are we going to change maybe what we do or what we assign as the conservation strategies to those areas given projections in climate change? And so for this national assessment, we basically asked, given some of this idea that we need to protect what's still wild, we need to create a more representative and connected network of protected areas. That's what we went out to do. We said, okay, that's great in concept. We can all conceptualize that we need to have a protected areas that protect all of nature's diversity and a well-connected network of protected areas. What does that mean? Let's take a shot at what that might look like. But then again, how might an explicit evaluation of climate change influence our conservation strategy for those areas of high value? Again, I know I'm throwing a lot out here. We're going to dive down in just a second. But the whole idea is, again, to sort of be explicit about trying to identify places, but acknowledging explicitly how an evaluation of climate change will influence what we might think of as a reasonable conservation strategy. So what do we mean by the wildest lands? Watson says that that's important, and then this Martin paper says that's important in others. Greg Atlett, who's actually my boss, conceptualized it as this sort of two axes of wildness. So any place on Earth can be sort of described in, that's not like an active screen, as if I touch it, it's not going to move. Okay, I've done that before. Ecological conditions, so going from a sort of novel or degraded system to pristine system. So there's something about the ecological character of places that we can measure, and we can say how sort of whole or intact are places. But we can also describe wildness in context of sort of freedom from control. So this is what in the Wilderness Act is considered untrammeledness. So places that are self-willed versus those that are under control, or self-willed or untrammeled in the language of the Wilderness Act. So any place can be sort of put into this two-dimensional space, with the places that are most intact or pristine or whole and most untrammeled being the wildest places. So it's these sort of two axes of wildness is what we call it. So you can consider any place, so go out and, if you can conceptualize this, you could actually measure it and say there's an ecosystem, and we want to improve its ecological condition, but we know we're going to have to intervene. We're going to have to do some management action. We're going to have to do some kind of control of some component of the system, be it actively managing a disturbance regime or propagule pressure or the hydrology of a place. We want to get the condition of the system more pristine. That's going to require taking control of some component of the system. And so we might consider that a pulse restoration. So we go in and actively intervene one time, and we hope that eventually sort of feedbacks within the system will take over. So we can go in and remove invasive species, or we can go in and reestablish the historical hydrology of a system. then let it go and let nature recover. That's sort of the idea of like a pulse recovery, a one-time intervention. You're going to sort of trade off the wildness of control with the benefit of overall recovery in the long run. So there are situations where you've got an ecosystem that is degraded ecologically that you say, we have to take control of multiple components. We're going to press it. So we're going to actively control propagule pressure, disturbance regimes, hydrology, you name it, to try to maintain the composition that historically occurred within a system. So an example of that, I was just at the conservation meeting in Madison, Wisconsin, and visited the Curtis Prairie, which is on the Arboretum there. It was an old agricultural field that for the past, 50 to 80 years, managers have been actively controlling. They've been burning, they've been planting, they've been weeding to try to restore what a historical composition of a historical prairie system would look like. It's required that press interventions to maintain all of those components. And so from a wildness perspective, it's highly trammeled, it's highly controlled, but for the benefit of to maintain a more intact and more whole ecological system. And then you can, they only have a few more of these. You can imagine a place that has its intactness and it's free. It's not managed by humans. So I'll go ahead and tell you the example here is say like the Bob Marshall Wilderness. We spent 80 years putting out fires there. So we influenced the disturbance regime, which degraded the system, created more contiguous fuel beds, and influenced the forest structure and composition. Oh, sorry, that's the wrong one. Sorry. So forget about the Bob Marshall Wilderness. I'm going to get to there. I've got ahead of myself. So there are situations, so just forget about the Bob Marshall Wilderness for just a second. This is the situation where if let's say, an exotic species invades a place, it will degrade the ecological condition. It can still be free. We're not doing anything about the weeds out in places, but it could eventually become dominated by exotics. And then, you can pick your favorite system and find a place that has either cheatgrass or kudzu or knapweed or the Japanese stiltgrass. There are places out there that we don't manage the system. It's completely free of hard human control, but it's degraded by the non-native species. Okay, so now get to the Bob Marshall Wilderness. Again, so we put out fires, we control the system to the detriment of the ecological condition, but we think there are some situations where what we might call latent resilience, and Andrew and I published on that a system that's degraded by putting out fires, if you just let the fires return, the system can recover and return. And here's a picture of the Bob Marshall Wilderness. This is a larch mixed conifer forest that, we put out fires for 80 years. Ladder fuels grew up. The system was at risk of losing the large old growth trees. A fire burned through, and in some places out there, they're still sort of maintained or restored that historical structure. So just again, this is still setting the stage, obviously, but the idea is that we can conceptualize, when we talk about what is natural, what is wild, what's a wildland, these are the primary features we're talking about. We could also talk about sort of recreational wildness, like the opportunities for solitude and primitive recreation. But from an ecological perspective and how ecosystem managers engage in wildland conservation, these are the two axes we primarily focus on. Again, to just reiterate what I already started with, the challenge is that this pressure of global change from climate change, invasive species, pollution, fragmentation, et cetera, is this great arrow of doom. I mean, that's obviously a little bit hyperbolic, but it's a vector that's pushing on the ecological condition. And so, Greg, who conceptualized this, even sort of conceded that there's scientific evidence that challenges the perception that eliminating human impacts and maintaining historical fidelity and not trammeling the land could all be achieved simultaneously on the same piece of ground. So with this pressure of global change, places up here that are self-willed nature, that have high ecological wholeness, high ecological integrity, fidelity to the historical composition, structure, diversity, function, is a challenge. These places, whitebark pine in the northern Rockies or throughout its range, that are, untrammeled and whole, but are being impacted by climate change. Can we still maintain those self-willed pieces of nature while we also maintain the ecological components there. That's the real challenge here, sort of from the Wilderness Society's perspective anyway. And I think ecosystem managers that are working in these systems. Okay, so now to get to the national assessment, we're trying to bring some data to bear on all this. That said, again, okay, now I'm done setting the stage. I promise I'm done setting the stage. This is our national assessment now to say, okay, let's try to evaluate how we may want to, what are those values, those wildland values that we may want to have extra scrutiny for conservation. This isn't to say these are the places where we're going to go after wilderness designation, or these are the places we need to include in our protected area system. These are just places that may provide an additional, warrant an additional look in terms of conservation focus. And so not only did Greg conceptualize this concept of wildness, but they also took a shot at mapping places that are relatively wild in the lower 48, actually all over the place. This is real similar to other efforts like Dave Theobald's human modification map. Recently, the update on the human footprint model from Sanderson back, it just got updated a few weeks ago and was published in Nature Communications. So it's basically the idea that you can take sort of stressors of ecosystems or components that we can actually map and say, where are the wildest places out there? So we look at what land cover, we look at distance to roads, we look at the population, so where are the people, night sky intactness, so where are the places that still have an intact night sky, where are the places that are free from pollution, and create an index and map the wildest places. Here, obviously, the light blue are the places that are relatively more wild than other places. Again, a lot of these that you've seen, like human footprints, wildness, human footprints, human modification, are all highly correlated. We've looked into that a bit. But they represent those places. And so from, again, to go back to one of those quotes I said, that there's needs to effort to save what is left of non-domesticated nature. There's need to protect whatever's still wild that's not protected. And so I've just thrown over large protected core areas here as black. And so we can already bring these data to bear on our work, on that work of agencies that we engage in to say, where are the wildest unprotected places? So I've done some work on, say, all National Forest Ranger districts to say, where are the ranger districts that are out there that have the highest wildness of its unprotected lands? And I can tell you the Salmon Chalice National Forest is the wildest in the lower 48. And so I met with those guys in Salmon this summer and said, you guys are stewarding the wildest unprotected lands in the country. So when they're engaging in forest planning, that's something that they may consider as saying, okay, well, if we're stewarding lands for the whole country, somebody in Chicago may really want there to be some sort of sensitivity to the fact that these wild, unprotected lands still exist out there, and they're in the federal ownership and management. So we can say where are the wildest places, at least we can take a shot at it. But this idea that, part of the idea that as climate change and other aspects of global change impact ecosystems, that these protected areas that exist here in black, we need to connect them. We need to make sure that this protected area system is more representative of the nature's diversity. So just sort of this, keeping wilderness wild in the future is about connecting the cores and protecting all the parts. And so now I'm going to step through what we mean by that. So one of the things that we did is said, well, you hear all the time, look at the climate adaptation literature, and you see people making reference to this need for a connected system of protected areas or a connected network of protected areas. And very little data exists out there, at least at a national scale, to say, well, what might that look like? And so what I basically did is take that wildness map. I took our large protected cores and I told this model, I said, find the wildest corridors between the large protected core areas. As an aspirational map, yeah, then basically, and also as a way of trying to bring some data to bear on this concept of creating a connected network of protected areas. And so, again, the black areas are the big core areas, so Yellowstone, the Frank Church, Bob Marshall and Glacier, just as an example of here, the Smoky Mountains. So all I did was said, how might we create linkages between those big protected areas through those wildest or most natural, least human modified lands? So the green areas are those sort of high-value connectivity, those high-value corridors that may serve as connections between it, sort of assuming that most organisms avoid human-dominated places. So if you want to create that system of connected protected areas, why not focus on the least human-modified places? You may have the best opportunity of protecting the sort of long-term dispersal of the most number of species if you focus on those areas. So again, this is just a shot at sort of trying to map out what a well-connected system of protected areas may actually look like. And we know that, again, sort of keeping wilderness wild in the future, this is a shot of 11 grizzly bears in the Swan Valley. This is the Bob Marshall ecosystem, Bob Marshall Wilderness. This is the Mission Mountains. And so all this area is the old Plum Creek, Montana legacy lands. And so obviously grizzly bears aren't staying in the wilderness. And so, this is just the shot to show that, these ecosystems, protected area ecosystems are fluid, and we have to think about what's going on outside them and acknowledge that they may need to be connected and make sure that, the grizzly bear populations in the Bob can be maintained. So to shift over now, so we can identify where the wildest places are. We can identify, at least, sort of take a shot at identifying where important linkages are in terms of connectivity or creating this connected system. And then there's this idea about making sure that it's ecologically representative. So how do we expand the diversity of our protected area system? Again, sort of in the age of climate change, if we want big, wild, connected, and representative protected area system. This isn't a new idea. The Wilderness Society platform in 1935 recognized that one of our number 7 in this big list, that what we're about as an organization were to preserve as many and varied examples and primitive of the primitive as possible. All the Leopold and Fannin County Almanac made this, that each biotic province needs its own wilderness. So, and there's other places where he references this idea that we need to have representative areas that are in our protected area system. And so with those things in mind, we went out and said, okay, we've got maps of the ecosystems in the lower 48. This is GAP land cover data. All those different colors are classified to the National Vegetation Classification System. So, what I like to say is that the different shades of greens and browns are ecosystems that we would recognize: northern Rockies, mixed conifer forest, sagebrush steppe, those sorts of things. So what we did was that we took this map. There's about 576 ecosystems, different colored on this map, and we overlaid as a shot at this the wilderness areas, and we said, this was a project we did in 2014, which is the 50th anniversary of the Wilderness Act, and we said, 50 years post-Act, what have we captured? What do we represent? What is this network that represents nationally 110 million acres? What's the ecological diversity that's represented there? Where are the places that are well represented and where are the places that are insufficiently represented? So I'm just going to do a little animation again. It took a long time to figure out how to do that, so let's do it again. So those are the wilderness areas flashing. So the point is, what we did, we calculated the total area of an ecosystem in wilderness, the total area on all federal land, and took the ratio and multiplied it by 100. So we're basically representing the proportion of an ecosystem that of that which is on federal land that occurs in wilderness areas. And then we can map that back out. So the black areas there's absolutely none of these ecosystems in wilderness in the lower 48. The red areas are less than 10 essentially, so there's less than 10% of the reddish hues of those ecosystems that occur in wilderness, and then the green areas are above 20%. And you can see the high elevation areas of the Crown of the Continent, the Greater Yellowstone, and the Sierras. Lots of high proportion of those ecosystems occur in wilderness areas, and then the yellows are kind of in between. That's 10 to 20%. There are some, what would be sufficiently represented? Nobody really knows. There's been some targets set out there, like 17%, and so we're just sort of saying here are the data. But what we can do now is to say, well, if we want to expand the wilderness system or any protected area system, be it GAP 1 and 2 land, so those areas that are managed and maintained managed to maintain biodiversity, we can calculate the very similar statistics on this to say, where are the places that are insufficiently represented, where are the places that are well represented, and then if we're talking about some new management action or some new legislative proposal or some new executive proposal like a national monument, we can say, these are the places that are not well represented. These ecosystems don't occur very much in a protected area system. And just to give some examples, you saw the map and just, maybe from your geography, the plains is woefully underrepresented. The sage of Great Basin is woefully underrepresented. A lot of the east doesn't occur, much of it occur in wilderness. And so just to sort of boil that down a little bit, 61% of alpine vegetation that is on federal lands are protected as wilderness. That's probably what people would have guessed, that there's a high proportion of rock and ice in wilderness. But also only 3% of grassland and scrub. So if you combine some of those ecosystem types and just say, how much of that grassland, scrubland systems are in wilderness, only 3% is. So we talk about sort of all the diversity out there, and we want to create representative protected area system. We think this gives us a bit of an insight into where are those places that might be priorities. So from an ecosystem perspective, that's the way we sort of handle things. But then there's the sort of issue of, what about diversity, so species diversity? And so we used, Clinton Jenkins published this paper last year that basically, this is a map of sort of rarity-weighted richness, but it also includes the proportion of species distributions that are in protected areas. So basically, you take all a bunch of different species distribution maps, you overlay them, and you could add them up and say, what's the species richness out there? That's pretty easy to do. But then you could say, weight that by its rarity. So take small species that have small geographic ranges, give them an additional weight. So if there's species that only occur in this one little drainage in the Smokies or someplace in the Sierras, that species gets a higher rating. Then take that distribution and say, how much of that is already in a highly protected land? So if that 100% of some little salamander distribution is in the Smokies, it's already well protected. There's nothing where you can do in terms of prioritizing its conservation from at least in expanding the conservation system. So that's what this represents. It represents basically hotspots of range-limited or endemic species diversity that's weighted by the level of protection of that species. And so we use that as, if we want to create a representative system, a protected area on ecosystems, I've already showed you those maps, we use that ecosystem map. This is how we can say, where are our priorities if we're looking at the species level? So where are those range-restricted endemic species and hotspots of those that we may want to expand and be extra careful about, or just bring to agency planning? So the Nantahala-Pisgah National Forest is undergoing forest plans right now, and I can tell you that the roadless lands on that national forest are in the 99th percentile in terms of diversity for all the other national forests they're sort of undergoing similar planning efforts. So it's a way of bringing sort of data to bear on these conversations about what should we do in terms of conservation in the future. So ultimately, we can say, again, just to reiterate, we can say where are the wildest places that are important for connectivity, that are composed of underrepresented ecosystems and hotspots of endemic species diversity. And so just to, here are the four maps that I just walked you through. This is for a publication, so we stopped calling it wildness for the publication and called it ecological integrity. But we create what I call a GIS sandwich. We have a big sandwich. We normalize each of these indices, and we sum them up. Well, my joke that I normally tell is we use a very complex algorithm called addition. That's my. We have done other things just that are more complicated, like do principal components analysis and all that kind of thing. But this is the most intuitive and makes the most sense, and it's easiest to explain. So we basically take those four different inputs that I showed before, rescale them from 0 to 1, and then add them up. So we can come up with a heat map of where are the places that are the wildest, that are important for connectivity, and then are composed of underrepresented ecosystems and species. And here's the map. So red areas are the places where multiple of those values align. The black areas, again, are the protected areas of our existing system. And so if we want to, again, sort of focus as a nation or as an organization on what are our priorities for completing the system of protected areas or expanding our conservation reserves, these red areas may give us some indication of places that are the wildest, that are important for connectivity, and that are composed of either underrepresented ecosystems or species. So highly dominated in the West, obviously, because of the high number of existing protected areas, the high degree of ecological integrity or wildness. So there's those things sort of weight this. But the Appalachians have some of the top 10% places that are all throughout the East. So this isn't, it's obviously sort of visually striking the West dominates, but places in the East, and even places in, the Missouri and Arkansas and Oklahoma and the Ozarks, there are some important sort of opportunities for creating at least regional, connected, and representative networks of protected areas.
Maine.
Yep, absolutely. Yeah, no, we've got a guy in Maine that loves this map. We don't have anybody working up here, but yeah, absolutely. So just to zoom in, Iowa always, I'm not from Iowa, I have nothing, against or for Iowa, but I always, there's something, it's always sort of shows itself to be low value anytime I've run these analysis, connectivity and all that sort of thing. So I just wanted to show that you can zoom into places that at a national scale don't really do much for you. Iowa is about as blighted as you can get on this map. This is the lowest values. But even in these kinds of data, you can zoom in and rescale the statistics. So basically, you just throw this color ramp over the new histogram that's represented within this map extent so that you can see, well, even within Iowa, where are those places that are still relatively intact from a relative perspective? And so, places along the Mississippi River, and I don't know geography of Iowa at all, but this is always fascinating to me to zoom into some of these maps and say, you know what, if you're interested in the place in your backyard or in your community or in your county, we can do those sorts of things by just rescaling the color ramps and saying, where's the place that's important for your area? So the other thing we can do is, this is a bit kind of a crusade of mine, is to making bivariate maps much easier. So rather than just mashing everything together and summing, we can say, okay, where are the places where some of those values align? So if we want to say, we're going to reiterate, where are the wildest places important for connectivity and composed of underrepresented ecosystems and species, and then adding them up, that provides some indication of high priority, high value areas. But where do some of those things align, and where where are the places that are, that co-occur, that are both are high value places? So I created these bivariate maps. So this basically is the priority binned up into 4 different bins and I combined intactness and connectivity. So I took wild and connectivity and created one index of that, binned it up into 4 bins, and then said, okay, where are the places that are highly intact and important for connectivity and a high priority for representing underrepresented ecosystems? And so the red areas, which again dominates the west but also in the east, those are the places that are relatively wild, important for connectivity, and composed of underrepresented ecosystems. That one actually is not as interesting to me as these other ones. So in this map, this is a bivariate map showing the intactness and connectivity importance and biodiversity. So this is that range-limited species. And you can see, okay, the red places are where both of those values align. The high-value places of those 2 qualities of land align. You can see there's places in California and Sierras and in the southern Appalachians. And so those places are important for connectivity, they're relatively wild, and they're really important for biodiversity. Much less frequent, they're much rarer, those places where those 2 things align. But these bivariate maps allow us to do that. So then, basically I'm just taking those 4 maps and making pairwise comparisons. So this is ecosystem representation and in the biodiversity index. And again, you can see the places that are in red are places that are a high priority because they're composed of underrepresented ecosystems, as well as important for maintaining that hotspots of endemic diversity. So, okay, so that's our wildland map of wildland priorities. So if we want to complete the system, let's bring some data to bear on to talk about the things that we may value, especially as an organization. But again, as I started, how do we develop these conservation strategies for those places, or for all places really, that are informed by climate change predictions? And so, again, to go back to one of these Kariba quotes, in the face of climate change, species-driven protected areas will increasingly require active intervention. So again, that idea that there's these tensions potentially between ecological integrity and untrammeledness or self-willed nature. So how can we take this map of values or this conception of values, conservation values, and take a look at climate models and say, okay, well, fair enough, let's take a look at how these places map out on the ground. Conceptually, we published a piece in the Pinchot letter. We were invited to publish this piece to take on this idea about wilderness and conservation strategies in the Anthropocene. But we went from there to the conception, then we took this data approach, which is what I'm going to show you now. But first I'm going to show you another conceptual model. So we're big into these bivariate conceptual models. I know you're having to do a little bit of mental gymnastics to keep up with. So this one here shows wildland values. So those things that I just walked through, wild, connected, underrepresented ecosystems and species. And this is sort of some projection of climate vulnerability. So you can map out places. Actually, let me just walk through. So again, from on this axis is wildland values, what I just showed you, and this is some measure of climate vulnerability going this way. So you can take and you can say, down here are places that are high value, low vulnerability. These are places that are high value, high vulnerability. These are places that are low value, low vulnerability, and low value, high vulnerability. And you can say, well, what might we do? People say all the time, well, we need to consider climate change. Okay, well, what does that do? Like, how does that adjust my thinking to consider climate change? Well, in places that are high value, low vulnerability, those are places that sort of traditional wilderness-like reserves may still make sense. They're places that are composed of underrepresented ecosystems. They're still relatively wild. They're important for connectivity. And climate change vulnerability is expected to be relatively low. So wilderness may still be a highly relevant conservation strategy in those places. And then places down here that are low value, low vulnerability, these are places where restoration to a historical model may still make sense. The place may be degraded. It may be in need. But because the vulnerability of climate change is predicted to be low, maybe the model of historical range of variability, so restoring the structure, function, composition historically composed that system may still make sense. Whereas if a place is expected to be highly vulnerable to climate change, it's a place where we may call innovation. So, we can't sort of invest in a historical model of restoration. We may need to invest in a future range of variability or some kind of innovative restoration strategies. And then the high value, high vulnerability are places where they're composed of lots of values that we care about, but we may need to allow for expanded decision space. So we may need to say, well, wilderness may not be the right thing to do there because we want to have the option of trammeling to maintain that ecological composition, stuff that I walked you through to begin with. So just to, I think I'll get through this. So how do we measure climate vulnerability? So yeah, wildland values, I just walked through that. But what do we mean by this? I mean, there's lots of ways of doing this. I'll talk about some of the ways we've been looking into. One is just multivariate climate shifts. So you take the sort of principal components analysis of the current climate, which is in the big cloud of blue, so that represents the current climate domain. And then you do what's the future climate domain, and then you basically say how different are those at any given place on the ground. So conceptually, you can think of a pixel, of a place on a map or a place in the world as having some sort of multivariate climate space. So here it's just two dimensions, so wet to dry and cool to warm. And you can imagine sort of the species and organisms having, the gray cloud represents sort of some, range of variability that organisms can tolerate that's not going to sort of push it into a new regime. And so if the future climate change is expected to be within that domain, there may be less of an impact on things like changes in disturbance regimes and mortality events and all the things we may think of as some impact or degradation to an ecosystem. Whereas if the multivariate shift is expected to be large, that may be more vulnerable. Those places may be more vulnerable. So that's what we started measuring those sorts of things, just using some pretty simple principal component scores and calculating the distance for every place, every grid cell. So every place we map, basically, this multivariate dissimilarity. I'm not going to show you those data, but that helps set the stage for what I'm going to show you, which is this multivariate climate velocity. And this is stuff that Carlos Carroll has published on and others. And there's a paper that just came out that tweaks this a bit, but just for simplicity's sake, what this does is says, okay, that multivariate climate space that might be considered for an organism or ecosystem, it's climate happy space. Where is that climate happy space going to be in the future? So it says, here's my happy space right now. Where is it going to be? Where might I have to go if I'm an organism and need to track that happy space in the future? And it just takes the minimum distance. So it says, how far am I going to have to go to maintain that multivariate happy climate space? And then you divide it by the time step for your climate model, and so you come up with a rate of kilometers per year. So it basically is a measure of how far in geographic distance will, and over what time period, will that multivariate climate domain move in the future. And so a lot of times when people do this sort of thing, again, our ultimate goal is to map climate vulnerability for that conceptual framework. And what a lot of people will do is just use the ensemble of multiple models. So they'll take a bunch of different models, they take sort of the average of those models and say that's what we're going to use as our metric of climate vulnerability. But we know that there's variability in those models. So this is the ensemble of 15 different general circulation models. But we know there's a lot of other general circulation models. There's other lab groups out there. There's other efforts that are doing their own projections of climate change, and there's variability among those projections. So I'm going to start, keep that in mind, I'm going to start showing you the means, or the central tendency of lots of those models. So this is climate velocity. This is that Carlos's work at where in the future will that climate happy space expected to be. So you can see this is kilometers per year. So the dark areas are 50, maybe up to 57 kilometers per year. The light areas are less than 1 kilometer per year.
In order to keep in your happy zone.
Exactly. So I'll just go back to this conceptual model. So now we can take these two maps of the wildland values that I started with and this sort of central tendency of climate velocity. We can overlay them in a bivariate map. I'm a big fan of these bivariate maps. To say, okay, where are the places that are high value, low vulnerability, low value, low vulnerability, low value, high vulnerability, and high value, high vulnerability. So the blues, the dark blues are those high value, high vulnerability. Actually, I'll just instead of being, so basically we've mapped those out, just areas that are low value, low vulnerability, and here they are. So those are the places where restoration may be an important conservation strategy. Here's the places that are low value, high vulnerability, where that innovation or maybe a future range of variability model for how do we improve the ecological condition of a system. Well, maybe historical doesn't work as much. Maybe we should invest in some kind of future range, so predicting what systems may be composed of and using that as our model. These are the places that are high value, low vulnerability, the places where we still might be able to invest in wilderness-like reserves. And then here's the places that are high value, high vulnerability. These are the places that it's a bit of a conundrum, but we want to protect those values that are there, but also provide for potential, expand decision space or flexibility for managers to be able to trammel places to maintain the values, the high values that those places are composed of. So again, just to go back to this idea, we haven't addressed the variability among model. I started out doing what everybody else does, which is focus on the ensemble or some kind of central tendency of these models. But, an older version of this, if you say, well, take any individual one of these maps and map it in that bivariate space, so values and vulnerability, using all of these individually as an estimate of vulnerability. And this is an older model, but it's the same exact principles of high value, low vulnerability. And you were going to assign your conservation strategy based on the differences in the general circulation model, the differences in those maps, the different efforts. You get different answers. So you say, well, where do they align? I don't know. Do we invest in wilderness? Do we invest in innovation? Do we invest in restoration? How are we guided by that if there's so much variability in the models? So what I've been working on really recently is to try to figure out a way of mapping the certainty we have among those GCMs, those different general circulation models that predict climate vulnerability or climate velocity. So we can do things like, obviously I've shown you the mean, the central tendency. We can map the standard deviation. So the spread on every given pixel for climate vulnerability there, we can map it that way. But I've also been doing things like binning the velocity up into 4 bins and then counting the number of times that a pixel occurs in any one of these bins. So I know I'm going faster here, but I'll just show you what that looks like. So ultimately what we're able to do is to map the places where every single one of the models agree that these areas should be assigned to these places. So it limits the places where we have confidence, but it reveals the places we have confidence as well. So these are the places from those maps that I showed before where I'm only showing you the places where all the models agree, and there are 18 GCMs we looked at. Actually, there's 9 GCMs by 2 different emission scenarios. So these are the places where we can say, you know what, all the models point us in that direction. So that's probably all I have time for. I'm going to try to finish up. But so one of the things I wanted to go back to is just, read this article and thought it was pretty cool. This, most great stories of adventure come furnished with a map. That's because every story of adventure is in part the story of a landscape, of the interrelationship between human beings and topography. Every adventure story is conceivable only with reference to the particular set of geographic features that in each case sets the course literally of the tale. And so to me, it's like, I think that's a really cool way of thinking about all these mapping things that we can do now. It's pretty easy to do all this stuff. and to set the course of, you know, our organization or of a federal agency or the country's sort of conservation goals. 80 years ago, literally, this was November of 1936, Bob Marshall published this piece in the Living Wilderness, which used to be a magazine that we published, of the remaining roadless lands in the lower 48 that are above 300,000 acres in size. And so this helped set sort of the Wilderness Act in motion. This was sort of a huge influence saying, you know what, there's places out there where we haven't gone in with our bulldozers and created, you know, a roaded network. These places are precious. We got to take them, you know, protect these. And so I guess that to me, the sort of doing this mapping from somebody that started on their hands and knees is pretty exciting, but it's also, I think, just to sort of be clear, I don't think you can ever get away from getting on your hands and knees and actually looking at some of these ecosystems. So mapping is cool. It can be sort of inspirational, and it can sort of make you be critical about your values and be rigorous about your thinking, but at the same time, you still have to go look. So I think that's all I got. That's it.
So I have two wonders. One is in the little squib that advertised you, it said that you were interested in climate, but other changes like development and weeds. So you haven't really addressed that.
Yeah.
I don't think I can ask you in the remaining minutes to do that, but it would be fun to hear what you say.
Yeah.
The second is connectivity.
Yep.
So that's a major thing. And I think that just listening to you, I think you convinced me that it's such a cool idea, but it's impossible. And that you know, the maps you had that showed the connections, they're connecting things marvelously, but if you just try to think of moving across that, and I wonder what you think of instead working to think about how we would connect it, moving seeds, moving amphibians, and so on. I guess I leave that question first if you want to come back to the other.
Yeah. Yes and yes. Yeah, I mean, that to me, the model, the connectivity model that we published was aspirational. I mean, there's no question. It was an attempt to say, where are the wildest or most natural places between our protected areas? That's what I think we mean when we say we need to create a connected network of protected areas, and we say that all the time. We, as in like conservation scientists, say that all the time. I think what I've thought most about is not necessarily moving things around, although what I think about that, but not as rigorously as I think about, okay, what if you just overlaid things like the 4-lane interstate highways? Those are the pinch points. Like we could do, you know, the way I describe it is like it's like Liebig's law. You know, like that's the limiting resource. That's the limitation to movement. Is you could all of those big corridors. You could say, yeah, let's protect all of it as wilderness, and we still haven't added. You know, we still haven't removed the mechanism that limits movement, which are those you know, big highways or big developed areas. And so I've thought about it in the context of, you know, the way our organization focuses almost primarily on federal lands issues. And so if we're serious about creating a connected network of protected areas, we might want to be involved in things like federal legislation of Department of Transportation funding and mitigations and those things. But certainly the idea of moving stuff around comes up. It's just something that I haven't thought as much about as sort of challenging our organization internally to say, well, what are we going to do about these areas? If we're really serious about this, these are important pinch points. These are important mechanisms to address. On your point about invasive species, absolutely. That's part of why I ended with you got to get on your hands and knees. Not that you have to get on your hands and knees to see some of those invasions, but I think it's a limitation to some of the ecological integrity or wildness data that we're using, because it doesn't, you know, some of that stuff in the Great Basin is highly wild. Well, that assumes that it's got high ecological integrity, and we know that there's places out there that's just totally degraded by cheatgrass and tamarisk and all kinds of other things. So it is a limitation, and, you know, so yes, it's important, and I mean, it's part of where I came out of is this sort of invasive species work, and I think it's a huge limitation of some of the maps we're using.
Well, those are the places you're going.
Yeah, I mean, that's why I think you always have to go look. I mean, that's, you know, obviously. But.
So thank you for the awesome talk. I really enjoyed it. I'm still digesting the maps.
Yeah.
So it looks like a lot of those areas that have high value are still like high elevation mountain ecosystems, right? And they already represent 61% of federal land, and 3% of grasslands
Yep.
are federal lands, but they don't seem to be high-value areas. So I guess looking at those maps, it seems like we're reinforcing that mountain ecosystems need to be protected. So how would you make the argument that grasslands also need to be protected?
I mean, this is where I think these maps come into play. Is that so? You just identified like a primary tension here. Is that if we're focused on protecting the wildest places, those are the high elevation places. If we're focused on expanding the protected area system to be more inclusive of the underrepresented ecosystems, those are the low elevation lands. So there's a tension there. I mean, I can tell you when we're working on the Gallatin Forest Plan, that shows up. The highlight area, high elevation is the wildest, but the underrepresented stuff, all that stuff is well represented. The underrepresented stuff is the mid elevation land, the mid elevation forests. So this obviously is hard because it's a bit, there's a lot going on, but these, I think, get it, that's trying to find, okay, where are the places that are, and I've smushed connectivity into this too, so you can't quite see exactly what you're talking about, but to me, this is the way to address that, is to find where are those places where these values align. So we know there's places that are, say, highly intact and underrepresented. That's the high elevation stuff. But there's lots of stuff out there that are the grasslands, that are the sage steppes, that are relatively intact and that are underrepresented. So I think you've identified definitely like a tension in terms of what is it we value. Do we want to be more representative, or do we want to be protecting the wild? Well, I think we need to be thinking about both, but so you have to sort of be careful. But that's a really important tension. I don't think I answered your question, but yeah. Thanks.
So it's kind of a follow-up on John's question, but it does refer to grasslands. The early part, all of these maps, kind of start from what do we have right now to work with.
Mm-hmm.
And so, except for the Curtis Prairie, it looks like the tallgrass prairie is toast. It's just white on all of these maps. And so later on, you say, well, that's a place where we need innovation.
Mm-hmm.
Do we still have the species to do it if we wanted to?
Yeah. You need tallgrass prairie experts in the room. I don't know. I mean, it's a great question. I mean, it's a great question.
It's just all of it's cloud, and so it's on your map, so there's nothing there to work with.
Yeah.
Well, there's the foothills of Kansas.
A little bit.
Yeah.
A little bit. The officers' polo grounds at Patterson Air Force Base is tallgrass prairie.
So like in Illinois, only 1% of Illinois is actually intact prairie.
I'm surprised.
Amazing.
1%.
So much.
So much of the state.
Yeah, I mean, I'm not going to answer your question either, I can tell you right now, but because I don't know enough. But I think, this is, the question of what do you even have to work with actually is a really important question. You're totally right, is that, if we don't have any of the sort of historical components of the system left, then it's going to have to be something other than historical anyway, right? I mean, I think that's what you're getting at. So, yeah.
We're not going to have chestnuts.
Well, that's an interesting case of genetic trammeling that we're doing right now, honestly. Yeah, but.
Yeah, I mean, as I was thinking, as you were talking about eastern national forests. Right? And if in the early 1900s we had said, how are we going to protect, what can we do to create a system of forests in the east? Following this, we would have gone out and tried to find those little tiny pockets of remaining forests that hadn't been harvested yet. That's not what we did.
Right.
We went out and found the most degraded lands and bought those, right? We didn't limit ourselves to the land that the federal government already owned, and created the Eastern National Forest System, which now, in hindsight, looks like a brilliant thing to have done.
Yeah.
Right. So when we look at Iowa or places like that, is the best strategy to go out and say, oh, here's an acre of pristine tallgrass prairie. Clearly, we want to do something with that, but we're being kind of drawn away from thinking about what about that, million acres over there that could be tallgrass prairie 100 years from now.
Right. Yeah, and that's a great question. I mean, it's so funny. I come from Appalachian forests, and it was the lands, there's a paper written on it's the lands that nobody wanted. That's what became the Jefferson, the Cherokee, the Pisgah, the Nantahala, the George Washington, the Monongahela National Forests, where the lands were like, they're low productive, they've been cut over, they're low productivity, they're steep. Like, sure, you guys want to...
Highly eroded.
Exactly. So, in fact, that recognizing that was exactly what got me interested in this idea about representation in the first place, is standing in like a maintained bottomland hardwood forest in Appalachia, and you look across, and you're like, there's, Black Angus cattle grazing fescue just through what you can see, but like somehow this little patch of forest is still maintained. Like, oh, that's interesting, because the stuff that I've been working on the Jefferson is totally this like acidic soils, is not very diverse. This is amazing diversity, and yet it's in private hands. So I'm just reiterating. I think I'm not answering your question either, but I think that it's a really interesting point to consider, and it speaks to close to home for where I sort of started thinking about this stuff to begin with. Yeah.
I really like your framing of global change. I think that's really helpful. And I'm just wondering, given all these new ways of prioritizing different spaces, to what extent are we able, with the tools that we have, to operationalize those needs? And is this really a back-end problem? To have the political tools to make what we think is important happen? Do we just scratch the Wilderness Act? What do you think about sort of the future of those?
Yeah, that's a great question too. Those in the back of the room, tell me if I'm not asking your question right. But do we have the actual tools to even do any of this, be it protection, restoration, innovation?
Or do we need to change them? There need to be a paradigm shift in how we think about restoration projects or conservation. Yeah,
I think that, some people will argue that we don't have the will, so stuff it's going to be wilderness anyway, so we should just protect that. I don't think that, but that's an argument that uses, like, there's no way we can do the restoration that needs to be done, so, let's set aside these places. I think where we're talking in the organization is that there does need to be a bit of a paradigm shift, and we need to be thinking about creating large-scale experiments with some of these things. So there's sort of, in the age of climate change, managers, and we're all being called to do innovative things, like think differently about the way we have normally done resource management and restoration and conservation protections. But let's not do those in a willy-nilly fashion. Let's not do a little bit of restoration here, a little bit of innovation and translocation here, and a little bit of wilderness protection here. But let's set these things up as big, large-scale experiments where we do innovation in this place, and this is our zone for doing innovation. This is our zone for doing restoration. This is our zone for accepting change and figuring out how nature responds to these challenges. So I think that is a paradigm shift. There are vehicles, there are things like forest planning, processes that could be a way of getting that interjected into the way we manage federal lands. Whether or not there's any sort of mandate for that, I don't think there is yet, but I think we are thinking about this, that we do need to have a bit of a, paradigm shift. I don't want to overuse that term, but you're right. It's a totally new way of thinking. So